Good morning. Whoa, this is loud. Hi, and welcome to the Hitchhiker's Guide to Cloud-Native API Gateways. My name is Leander. I'm a principal software architect working for Kuavia. We're a small project house located in Munich. We have a booth here. If you want to chat to me, come by the booth. We have cool sunglasses, perfect for this weather. Yeah, I work mostly for BMW. This is our enterprise customer in Munich, of course. So it's really hard to work in Munich and not work for BMW. And the idea for this talk came kind of out of a current project I'm doing. So let me talk you through this project. Well, a while ago, 1.5 years ago, almost 2 years ago, we had this situation here. Okay, we had a big monolithic system deployed on a Glassfish server, several REST APIs. It had a JSF UI. We have about, I don't know, 6,000 users at the moment. The system runs 24/7. It's really important. Without this system, the dealership of BMW cannot repair any cars. Okay, so it's kind of crucial in the after sales of BMW that this system is running. Of course, if you want an anti-fragile system, then the next thing is, okay, let's go away from this monolith and build a more, well, state-of-the-art system, right? On cloud-native infrastructure, microservice architecture, things like this. So we started off. We have a shared path. Okay, that's an OpenShift cluster in this case. So we get a namespace in that cluster, and, well, we deployed our first service. Everything was fine, okay? And for the new functionality, well, we route our users basically in the browser, or we have a client application in that case, towards those new services. Everything worked out fine. Well, guess what? Because it worked out fine, we implemented our next service. And things were still fine. And we implemented our next service. And again, things went pretty fine. But what you see here at the beginning, what we did is we kind of exposed every service quite naively using a separate route, a separate ingress in a Kubernetes world, using a separate host name. And we kind of realized, okay, if we go on like this, we kind of have a bit of a mess. Then people realized, hey, there are cool APIs out there. Can we also use those APIs? And we said, yeah, of course. Come on, third-party applications can also use our APIs. But those third parties, they said, well, can we have slight modifications on the APIs? You know, they're kind of big. We only need a certain subset of those APIs. Please only provide us a certain data. We said, yeah, you're fine. Here are those APIs. We implemented, custom APIs for them. So that was the situation then. And guess what? Well, we kind of got a new namespace because we kind of figured out, okay, well, we have some certain so-called capability services the other services need. And we use gRPC between them, so we don't have REST APIs there anymore. And you see here, those services in the first namespace, they all need to call the services in the second namespace. Quite wildly, okay? So there and there and there. And also, there's one service, it needs to talk to a pretty unreliable backend system, okay? So if you talk to this backend system, well, too much, right? If you have too many concurrent connections, the system will go down, for example. Not so good. The system is not there a lot of the times. Long timeouts. I mean, this system has like timeouts of, well, I don't know, sometimes it takes 7 seconds that the system is responding. And last but not least, then some internal systems, they said, well, can we also talk to your services, the other services you just built, security services in that case? We said, yeah, we're fine. Now, a bit exaggerated, okay? It didn't exactly go this way, but you see my point, I think, right? If you continue like this, you will soon end up in API hell. Now, is kind of a part of my abstract. I think good APIs are the centerpiece of any digital product, right? We're building digital products, we're building cloud-native applications with nice REST APIs. Possibly we want to expose those to the world. Well, we want to get money for the usage maybe, okay? We want to sell our product, we want to sell the API usage. So I think those APIs deserve proper management, okay? So it's super crucial that you properly manage your APIs from the start of the project, or otherwise you end up in API hell, what I call this. Right, so let's clean up this shit. So API gateways are there to help you to manage your APIs. So what I did here now is I introduced a so-called API gateway, and as you see here, I not only introduced only one API gateway, I introduced several API gateways. Now the first one for our prime users, I introduced this normal, API gateway. And for the user, it's now this one central place where they have to go, okay? This central API gateway. Every traffic goes through this API gateway, and I'll tell you in a second why this is kind of a good idea. For the third-party applications, for example, we had a slight variation of the so-called API gateway. Anyone heard of the backend for frontend pattern? Who has heard of backend for frontend? Yeah, a few, right? Now, backend for frontend is like a separate API where you have specific client-specific APIs, okay? Where you do transformations, where you do alterations of the translations of those things. Backend for frontend is possible to do server-side aggregation, right? If you think of a single-page web application, is it good? A single-page web application makes 20 backend calls, all with latency, right? Is that a good idea? Probably not. A good idea is to let the single-page web application make exactly one call, do a server-side aggregation of all the data the client needs, and then send like a bulk request and a bulk response to the client. So this is where you can use a backend for frontend style pattern. But in a way, backend for frontend is nothing else than an API gateway. Also, what we did, we hide the access to the monolithic system behind the API gateway as well, right? Because, well, I should have drawn the monolithic system a lot smaller. Because what we now did is, well, we applied the so-called strangler pattern. It's like every time we implement new functionality, we implement this new functionality using a microservice, and we extract the existing functionality from the monolith, right? So this way we kind of strangle the monolith and make it slimmer and slimmer until it at some point maybe disappears, right? Or is at least small enough. And all this is totally transparent to the client, okay? So this way here now, the client does not know anymore that there is a monolithic system or a microservice architecture. All the client knows is, hey, this is the endpoint I need to talk to use this application. And also in the backend, we also have this dedicated API gateway now to control the access to those backend services. And on the right-hand side, I have kind of an outbound API gateway, okay, to talk to this unreliable legacy system. So this is kind of an anti-corruption layer to to access unreliable systems, right? So this is what it should look like or can look like. When I was drawing this, who's a software engineer in here? Software engineers, software developers, right? Does everyone know this book? I guess we all read it in our computer science studies, right? Good old design patterns, Gamma et al. And I realized that the API gateway is nothing else than the facade pattern in software engineering, right? What is a facade? Well, a facade is an interface to hide the internal complexity of a complex system. And the API gateway does exactly that, right? Via the API gateway, well, there's only the gateway, and how many microservices there on the back end, the client does not know. So I think it's an API gateway is an essential design pattern for cloud-native applications. Now, why do I do that? Well, here are a few features or possible features I would like to have from an API gateway. First up, well, obvious traffic management, right? Request comes in, API gateway decides based on an HTTP header, on the path, on the host maybe, decides to which internal service the request should go. Maybe it does a path rewrite, like it comes in like /service1, and then I strip off this path prefix and forward the request to the backing service. Secondly, rollout and deployment, right? Also possible with modern API gateways. So this good old A/B deployment, kernel releases, any deployment strategy scenario that is suitable for your application, you can handle with API gateways. Next thing is quality of service and resilience, right? Good API gateways should provide some form of circuit breaking. They should provide retry behavior. They should provide timeout behavior and rate limiting. Security is an important aspect, okay? So those good old AAAs, authentication, authorization, access control. Terminate TLS, for example. Support for JSON Web Token or JSON Web Key Set. OpenID Connect, things like this, okay? So all those security concerns you can put into an API gateway. Protocol translation, for example, right? I told you that our internal services are talking gRPC. Now, if you want to expose those, maybe it's a good idea to do some gRPC to JSON transformation, or you do XML to JSON transformation, right? Also, all possible with an API gateway. Then this transformation bit, so fan out collect. This is kind of this backend for front-end use case, right? One request comes in, I ask 5 backend services, accumulate the response, and send one bulk response back. GraphQL support. There are some API gateways that support GraphQL. And of course, this good old observability thing. So I want integration into logging, monitoring, tracing, right? So API gateway as the first entrance into my microservice architecture could be the one that, for example, propagates the trace IDs, open tracing IDs to all those services. So all features, all functionality that are kind of useful, often required, and the API gateway is a good place to put those in. Now you might ask, well, this API gateway thing, I heard a lot about service meshes, right? I guess you all, this ContainerDays, you heard about service meshes, you heard about Linkerd and Istio. So what the hell is the difference between those? And I found a good blog post, and he said, API gateways are kind of for north-south communication, so inbound traffic and also outbound traffic, and a service mesh is for east-west communication, so for the communication between your services. And I found that quite appealing. Of course, both together make sense, right? A service mesh such as Istio does have an API gateway, kind of, right? It has this ingress and egress gateway. So it does make sense to have both, but today we only look at API gateways, okay? So in a nutshell, benefits. Encapsulate internal application structure, that's important, right? Provides client-specific API, backend for frontend, might reduce the number of server round trips, and it simplifies client code. But of course, there are a few drawbacks, okay, to the API gateway pattern. First of all, it's yet another highly available component that you need to operate, okay? If the API gateway is down, kind of everything's down, okay? No one can talk to your services. So really, you have to care for a highly available gateway. Also, the gateway kind of has the risk of becoming a development bottleneck. Now, what do I mean with this? Now, imagine a centrally managed API gateway, and you have to submit tickets to some ops team. Hey, I have this new service. Please configure the API gateway for those new routes. Okay, so this is kind of not very agile, not very clean. So from a proper cloud-native API gateway, I would expect that the developer can configure the API gateway somehow easily. And also a bit tricky, you should definitely avoid business logic in API gateways, because if you do that, then you have the good old enterprise service bus again, okay? And we don't want enterprise service buses anymore. So there are a few drawbacks, but I think it does make sense to have an API gateway. So for a comparison, those are my criteria, okay? First of all, I like open source, okay? I don't like to pay money. I like the idea of open source, and if you're in a project, in an enterprise customer, it's always hard to introduce a new component if you tell them, if we introduce that component, by the way, here's the bill of $20,000, yeah? So open source and no initial cost, at least, is good. I want good maturity, okay? I mean, this is a crucial part in my architecture, so I want good maturity, an active community, little issues, frequent releases. Well, you can look at the supported features. How does it is with the traffic management, deployment, security, etc. Is it DevOps friendly? right? Easy setup, operability. How many supported platforms are there? Is there maybe a CI/CD support? Performance, very important for an API gateway because an API gateway kind of is an extra hop. Okay, so small overhead, little latency, high throughput, super scalable, and good observability, of course. Good old cloud-native landscape. Let's have a look. Okay, I think the place to look are service proxies and the section where it says API gateways. I mean, this is their categorization. What I did is kind of a different one. Okay, I think there are 4 different categories. Build your own API gateway, full-blown API management solutions, lightweight service proxies, and then the new breed cloud-native API gateways. Now, build your own API gateway, just a quick one. I mean, this is kind of, imagine this as a framework. Like, who knows Netflix Zool? Who's using Netflix Zool? The unicorn is there, okay. 1. Spring Cloud Gateway, who's using Spring Cloud Gateway? 1, 2, okay, yeah. You can use Node, you can use Vertex, you can use Ballerina. Anyone using Ballerina? No. Camel, Express Gateway, Sentinel. The point here is you have to build your API gateway yourself, okay? You have to write code to do that. It provides a lot of flexibility, that's the great strength, but you have to write the code, okay? And this code here, this API gateway code, does not produce any business value. So I would argue it's maybe not the time anymore to write your own API gateway, right? You have better things to do, like writing business code and not technical code. I know we developers like writing technical code. Now, API management solutions, Kong, Tyke, MuleSoft, 3Scale, APG, definitely make sense in an enterprise use case, but for sure they're not for free, right? They definitely cost money. They provide additional features like payment integration for your APIs, developer portals with AP key management. They integrate nicely into enterprise infrastructure and your authentication infrastructure in the enterprise. Big drawback for me is usually they're centrally deployed and operated for the whole platform and for all the applications. So this is kind of exactly what I don't want from an API gateway, because here I have to write tickets to get my route into this API gateway. I didn't have a look at those. I'm not saying that they are bad, right? I mean, my prime customer, they just decided for APG, okay? I had a look at it. APG is nice. Yes, it has a nice fancy UI, but not very appealing to me as a developer, right? And it's not what I was looking for. Service proxies. Many choices. Nginx, OpenResty. OpenResty is the basis of Kong, for example. Envoy. I hope you all have heard of Envoy. Traffic, Apache, HA proxy. Yeah, they're lightweight and simple to use, and they provide a lot of the features. And I was kind of interested, hey, can I use Envoy? Can I build my own API gateway with an Envoy proxy? I mean, if Istio can do that, I can do that as also, right? So let's see. I've prepared a bit of code, and actually, Envoy is pretty easy to use. So here's a simple Docker file, okay? So I say from Envoy, in this case the developer one, and all I have to insert is a Envoy YAML file. Now I have to admit the Envoy syntax. Well, either you hate YAML or you love YAML. I kind of am in the middle. Okay, so this is the configuration of Envoy. Okay, so you have to write this, and all the features that kind of Istio offers, right? Circuit breaking, retry, timeout, etc., etc. Okay, I mean those are Envoy features or not Istio features, and that's a really cool thing. So in my opinion, okay, Envoy being labeled a service proxy, I mean Envoy for me is almost it's like an API gateway framework, if you like, right? Because you can kind of customize quite easily this here. So for me, this here makes a lot of sense, and if you stick with the YAML, that's not too hard. Hey, there you go. Easy, very, very easy and very, very lightweight API gateways can be implemented with Envoy quite easily. Has anyone heard of KrakenD? KrakenD? Is anyone using it? Yeah? I think they have the best logo and the best name. They say they're really lightweight, and this is an alternative to Envoy I want to show you. The containerization with KrakenD is pretty similar to the Envoy approach, right? So you from KrakenD, latest version, and I copy in a JSON file in this case, right? Same thing here. Either you love JSON or you hate JSON. I'm kind of in the middle again. Right? So this is the syntax it looks like. The good thing I find about KrakenD is that first of all, they claim they're super fast. I have not tested this, okay? I have not done any performance tests, but they have this designer here, okay? So they have this web UI, and with this web UI, you can then kind of here demo, and you can write, you know, do I need course headers, for example? I don't know. Google.com. I can add. Okay, I need the protocol. Specific hosts here. I can configure security options for my endpoints. I can do different things like rate limiting for the endpoints, protocol translations, and all that. So you can kind of configure your KrakenD configuration with this one, and then you press save, and then ta-ta, we get the JSON file, and then we use this JSON file. So I like that. It's kind of convenient, okay, to quickly configure everything. So with both, in my opinion, you're almost there, to be honest. Okay, you have no UI, but we don't need any UI, right? It's not too well, it is kind of developer-friendly. Well, you have to write a Docker file and a YAML or a JSON file. And if you have a proper CI/CD pipeline in place, well, you do the changes, you commit the changes, the CI/CD pipeline builds the new image for your new lightweight API gateway and deploys it to the platform, right? So it's, well, I think that's quite neat already. But there is a new breed coming, and that's the cloud-native API gateways. And they are a bit better. Well, technically I put KrakenD in here as well. But I want to talk about Ambassador and Gloo, right? Ambassador and Gloo are, in my opinion, like the fourth category. They usually build upon a service proxy, like Envoy, both build on Envoy, and enhance it, right? So you don't have to write this YAML stuff. What they usually have is a tight integration into the cloud-native platform. So they have a tight integration into Kubernetes. Now let's have a quick look at Ambassador. I really like Ambassador. So first up, we need to install Ambassador. Well, if you want to install Ambassador, you have several options. Well, they have a Helm package. If you have Helm as a package manager, you can use Helm. Of course, they provide several YAML files as well, so you can do a manual installation if you like. The default is the deployment as a, well, is the deployment, okay? So it's basically just a plain Kubernetes deployment. You can deploy it as a daemon set as well if you like. So let's do this in the background. Network provided. I've got a small cluster at Google running. Let's see, cluster info, everything good. Come on, please. Yeah. Okay. Good. Then Helm upgrade install. Well, I already installed it, okay, just to show you. So everything installed. Visio Cube, Cuddle. So what do we have? Okay. So currently here, you see here, there's the Ambassador service. Okay. So Ambassador creates automatically a Kubernetes service of type load balancer. So here we have the external IP of our API gateway, and currently we have three pods running of the Ambassador gateway. Right. Now let's deploy an application. Like that. And now the question is, when we deploy this application, now this is now my microservice application I just deployed. And how do you configure this application? And this is kind of neat. So for every, so you see here, this here, the annotations on the Kubernetes service, like this here, okay? So you provide the configuration for Ambassador as part of your Kubernetes service declaration, okay? So using this annotation here, I say, hey, I have this mapping here with a prefix slash, then please route this to the following service and the following port. Same here, I can do a path prefix, for example, and configure it to the backend. So all the configuration, timeouts, retries, translation, rate limiting, you name it, is all part of the service definition, right? And this empowers us as developers to, well, to be in charge of, hey, here's my new service, here's my new endpoint, please expose this on the API gateway. So this is kind of what we want, and I think this will be probably the future, right? I mean, this is rather convenient, and you don't need any special permissions to deploy this stuff to the cluster, right? So let's see if everything is working. Okay, where did we have the? So that's the demo application I just deployed. Okay, so that's the kind of the Ambassador demo application. This is the one endpoint. If I say /backend, then I use the other route. Okay. Okay, so this is Ambassador. I have 5 minutes left, but that's just enough time for Gloo. I think Gloo is also definitely worth a look at. The thing, Gloo works slightly different. First of all, you need a CLI for it, okay? So it's called, in this case, Gloo CTL, okay? I think this is kind of common use now. If you do anything in the Kubernetes universe, you need one of those CTLs, right? So I've installed this one, and installing Gloo is then a simple command like gloo CTL install gateway. You can install it as deployment or daemon set as well, again. You can install Gloo as a Kubernetes ingress as well. That's also supported. Ambassador does that supports it as well. So we do Gloo install gateway. So installs a few custom resource definitions, kicks in the namespace, kubectl get ns. So you see here, there's a new namespace created. So Gloo system. So let's have a look at this one. kubectl get all minus n up like this one. So you see here, Gloo is slightly more heavyweight, if you like it. It does deploy a few more things than Ambassador. I mean, Ambassador is really slim, okay? This one pod and the deployment, and you scale it. Here you have a few more things. You have this discovery thing, you have a gateway, the gateway proxy, and the Gloo API gateway itself, right? So concerning resources, probably slightly more heavyweight. But I like that they live in a separate namespace. Okay. What else? What I like about Ambassador, I said that in my previous talk, because how can you check those things, right? During development, for example, do I always have to go to the cluster? And in case of Ambassador, it's also possible to develop with Ambassador locally. Okay, so you have this Ambassador. It's just a Go binary. You can use it locally as well. Maybe if you're developing locally, you can use like plain Docker Compose, for example, to check all your configurations locally during development. Once you're done, you commit everything and then you let it deploy to the cluster. So I'm a big fan of staying local as long as possible. And once everything's done and fine and developed and working, then I commit and then everything's deployed. But hey, different development strategies. Okay, now maybe you have this question in your head, so which one should I use? And sorry, I don't give you an answer, right? So the answer is probably 42, right? That is why the Hitchhiker's Guide, if you know the Hitchhiker's Guide to the Galaxy, The 42 is the answer to everything. It's to live universe, the cloud, and probably API gateways. My personal preference for my use case is I will definitely just use plain Envoy. This is exactly what I need, right? This is super lightweight. Envoy is exactly the thing to go. Well, I like KrakenD as well. Cool name, cool logo, but good functionality as well. And if you have let's say a dedicated cluster, I mean, I'm on a shared path. If you have a dedicated cluster, I would definitely say go this cloud native API gateway route. Have a look at Ambassador or Gloo. I think both are fine. Do some performance tests and see which one is fit. Okay, I'm out of time. Thanks. Come to our booth and thanks for listening.